Okay, let's move on to the next unit. 22D, independent events. This is quick. Independent events. So we just want to know, we're always asking ourselves in the probability unit, does something affect the current probability? And that's our goal. So the notation is, so we saw, we have the first event A, but then we had a second event, and it was either just B, which meant that B wasn't affected by A, which means there's like in that first problem, there was a 15% chance I'm taking Park Road. It doesn't matter what happens, whether I take my bike or I walk, like 15% chance. So it's not affected by A. But then we saw the notation B/A, and that was that B was affected by A. It was dependent. B, the question is, what was the probability of B? It depends on A, versus it doesn't matter. Well, what are some examples? Some examples of that, for example, like flipping a coin. Rolling a die. And then in your biology class, you learn about from the Punnett score, like having children. Like if there's a 50% chance of having a boy or a girl, if you have a boy, what is the probability that you're going to have a girl? And then we know that from the Punnett score, it's always like 50%. It doesn't affect. B/A was affected. The idea is that whatever happened before affects a future probability. That's fine. So we say that the probability of A and B is equal to the probability of A times the probability of B. The notation showing that neither affects the other, then these probabilities, individual probability events, are independent. Then A and B are independent. Notation-wise, if we see the probability A and B is equal to the probability of A times the probability of B given A, then we see that B depends on A. So the question is B, are they independent on each other? Now, the third notation you might see is something that they say if B is independent, then the probability of B given A is equal to the probability of B. This is merely saying it doesn't matter what happened before, it doesn't affect B. That's what this is about. So is B independent? If B, given that A happens, is equal to if B, regardless, then B is independent. Question from the book. So this is what we're looking for. Question number 1. If P of A equals 0.5 and P of B equals 0.2, and P of A union B equals 0.6, show that A and B are independent. Well, this goes back to our union formula. It's very straight. These questions are I think this pen's running out of ink. It's very straightforward. Once you see the union, all this, you go, it's independent, you're like, okay, I have to show that the product of the individual probabilities equals 0.5, so I need to show. So let's see. We know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection. On the IB exam, you wouldn't need to rewrite the formula down. So the idea is we know that the union is 0.6. We know that the probability of A alone is 0.5. We know that the probability of B, the total probability, is 0.2 minus this intersection. Okay? we can see algebraically that the probability of A union B is equal to 0.1, and that is equal to the probability of A times the probability of B. Therefore, A and B are independent. That's when you see that and you see that, that's what you have to show. Let's look at the second problem. Now they might say in the second problem in the work, they say that A and B are independent with the probability of the union being 0.8, the probability of A equal 0.2, and they want you to find the probability of B. So let's leave that up there. Let's see. So what's given? Every math problem, they tell all the information is important. First, they tell you that A and B are independent. They tell you that the union is equal to 0.8, and they tell you that the probability of A is equal to 0.2. They want to find the probability of B. Okay, we're cool with that. So you know what? I don't know what B is, so that's I don't know. Let's let that be X. Okay. I have a formula here. The second the union, and you see this, get the formula down. So we know that the and maybe you don't need to write the probability. You could say 0.8 is equal to 0.2 plus X. And then you have the probability of the intersection here, but we were told that A and B are independent. So you know what? 0.8 equals 0.2 plus X minus 0.2 times X. Remember, because it's independent, the probability of A intersect B is the probability of A times the probability of B, X. Basic algebra problem. This would be a part 1 question. So what's going on here? We have, let's see, we have 0.6 is equal to 0.8x. X is equal to 0.6 over 0.8, 6 over 8, 3/4, 75%, whatever. So the probability of B is 3 over 4. One other term, the idea of mutually exclusive. It might not even show up, but I just want to discuss it. The term mutually exclusive. These sets are mutually exclusive. A and B are mutually exclusive, therefore the probability of the union is equal to 0. That's the idea of mutually exclusive. Good.